Okay, beginning of Unit 10, and this unit will be about series and when they converge and some other things. So we're going to begin by talking about what a series is. So an infinite series is the summation of a sequence, and a sequence is nothing but a list of numbers. So a sequence would be written, if we wanted to write down the sequence that kind of goes with this, we would write, like, we would use curly braces, and it would be, and the subscript is just, this is a generic term. So this is just saying term 1, comma, term 2, comma, term 3, comma, etc. to term AN. And that would be a sequence. Okay, so this is a sequence, is just a list. So a series, which is what we're going to spend all our time doing, a series is the sum of those terms. So the summation symbol, so this symbol is like it's a capital sigma, which is like a big capital S. So this means the sum. And we go from n equals 1 to infinity. That's how we read it. So we would say n equals 1 to infinity, just like when we do integration, we say from bottom to top. So n equals 1 to infinity of a sub n. So it's going to be a1, because the first thing we do is plug in 1, and then put a plus sign, and plug in 2, put a plus sign, plug in 3, put a plus sign, etc. Okay? Now, because it's an infinite series, the top is infinity, we also have this dot, dot, dot at the end, and that is saying that this goes on forever. The dot, dot, dot in the middle is just helping us say, okay, you just continue this pattern until the generic term. We like to list the generic term. You'll see more about that a lot later. And then plus dot, 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 meaning it continues on. Okay, so this is what we call an infinite series. Okay, and so again, a sequence is written in curly braces, and a sequence is a list, so you have commas, and a series is a sum, so you have plus signs. All right, so now we're going to look at what's called finding what we call partial sums, and that's important to understand about when a series would converge. And the reason we want to know about it converging is converging means that as I go n equals 1 to infinity, I can actually get an answer for the sum. And so the first series that we're going to look at, we will actually be able to get that sum. Geometric and telescoping. We'll just barely look at telescoping because it's not on the AP test, but it's interesting to look at. Geometric will be the other one. Well, those are generally the only ones we would ever actually be able to find the actual sum, but we can, with other things, learn when they do converge to something. We just may not be able to find what that is, okay? And so a lot of that will make more sense as we go. So looking at the difference here again, a series. Okay, the series has plus signs, and we plug in. So we start at 1, and we plug in 1, so we get 1 over 2, and then we put a plus sign, and then we plug in 2, we get 1 over 4, because we're plugging in for the exponent here, and so on. And you would continue on to plus 1 over 2n, and then actually this should say plus dot, 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 because this says infinity. So that actually, you should add that to your paper. The sequence that would be kind of like that, or a sequence that's not that sequence, but a different sequence, could be this sequence that's listed, but again, a sequence has commas, so it's just a list. Now, fortunately, they took out how we determine whether that converges or not, because it's very confusing. So don't worry about whether the sequence converges necessarily. But then we have the value of a series is going to be the limit of the sequence that that goes with it. And this sequence that's written here is what we call the sequence of partial sums, and you'll see what that is. So that's kind of how all those relate. And we're not going to worry heavily about that. We're going to just worry about finding them, and then we'll learn a bunch of methods for figuring it out when they fit certain patterns. So, you know, calculus is really big on patterns. Okay, so this chapter, more than anything, you're going to be looking, what does it fit? Like, what kind of pattern does this fit? Because then that tells me how I can deal with it. Okay, so it's really important to get that. All right, so we're going to write out the set of partial sums for this series. So this series just goes to n, which means that it's not an infinite series. So we're just saying we want to add up so many terms. Well, S1 means I'm going to go from n equals 1 to 1 on the top, because n's place here, Sn, is the generic term. So S1 means I'm just plugging in one term and that's it. So for this one, you would have 1 over 2 to the 0, because you'd have 1 minus 1, which is going to give you a 1. So this is what we call a partial sum. We add up one term. S2 means I'm going to put in n equals 1, put a plus sign, and then n equals 2. So plugging in 1 gives me 1 over 2 to the 0. Then I put a plus sign because it's a summation. And I plug in 2 because I just keep going up. So I plug in 2. So that's 1 over, remember I'm plugging in here. So that's 1 over 2 to the first. So this is going to be 1 plus 1/2, which is 3/2. Or 1 plus 1/2. Okay, but if I want to know the partial sum, then I could go ahead and add it to see what it is. Okay, S3 means add up the first 3 terms. Well, I already know the first 2 terms, right? Because I already did those. So now all I have to do is plug in 3. So if I plug in 3, I'll get 2 squared. So that's going to be, I'll write it that way here. So basically you're getting 1 plus 1/2 plus 1/4. Now notice that if we do it that way, also we kind of see the pattern, right? So we would know that the next term, if we added another term, would be 1/8 and then 1/16, and we could sort of see the pattern. Now, Sn. So Sn means I plug in 1, I plug in 2, I plug in 3, and then I continue on until I plug in n. So I'm going to get 1 over 2n minus 1. And that's what we call the general term there for the sequence that we have that we're listing. Now, if I want to write down the partial sum, it would be 1 plus 1/2 plus 1/4 ... And it's always 3 dots, not just however many dots you want. Only 3 dots is an ellipses that does that. So that's what we call the partial sums. Okay, so partial sums mean we just add up, you know, if it's S5, it means add up the first 5 terms. That's what partial sums mean. So technically the answer should be adding these together. So if we added all these together, for example, this one back here, this is the quickest way to do it so that you don't have to rewrite all the fractions. I just plug in, and so they all have the same denominator now. So it's 4 plus 2 plus 1, which is 7 over 4. All right. So the definition of a series that converges is that, and this is important to understand, to know, but we're not going to spend a lot of time on it because it's not really the way you would prove that something converges. We're going to have a bunch of tests, okay? But the idea is if you've got this infinite series and the nth partial sum, and that's kind of written bad, that should be capital S with the lower n there, is a1 plus a2 plus and so on plus an. Okay, so you add up the first n terms. If the sequence of partial sums converges to some value s, then the series also converges. and that limit that you get would be the sum of the series. If that sequence diverges, then the series diverges. Now, we're not going to talk about how you know if a sequence converges or diverges, because they actually took that out of the AP test, which luckily actually helps you a little bit because it's different and students get confused. So don't spend a lot of time concerned with this. So the next video is going to actually start talking about a geometric series and how we know if it converges, and some other series. And that's what we'll spend some time on, is how we know they converge. And we will not do it by finding the sequence of partial sums, which is why I think they took it out of that. It is the definition, but that's not practically how we do it. So we use other methods. Once we know that it fits a certain type of series, then we have different things that we try. Now, like a lot of things, like integration or anything else, you're not going to always know what to do. So at the beginning, when you are told to do it a certain way, really pay attention to why you're doing it that way, so that as you go, you can figure out on your own when you need that. So that's the end of this little short video, and then you need to watch the next video to finish the lesson.